You're going to third. We're still in the same order. That hasn't changed. All right. So the last thing we need to talk about with a relation or a function is domain and range. Okay. Domain and range is probably the hardest concept for any of you to grasp. Okay. So domain. There is a certain word that I want you to use to remember what these mean. Okay. So the first word is Dixie. D-I-X-I. Okay. Dixie. Okay. Just fold it in. Fold it down and fold it over. Yeah, you're good. Fold that down and fold that over. Okay. So, Dixie. Take a look at the line that it creates. It's a line that goes from left to right, which is your what axis? X. X. So, Dixie stands for, on the inside, Dixie stands for domain. I stands for input. So your domain is your input, which is the same thing as your X values. Bless you. Okay. So Dixie stands for domain, input, X values, independent. Okay. So if I ask you to list me the domain, you're listing me every X value that you can have in your equation, on your table, in your graph. Okay. Range. Obviously, it's going from top to bottom. And the word we're going to use is roid. Dixie Roid.
Is that a real person?
I don't know who came up with this. Again, I steal all of my ideas off the internet. Great website is Math Equals Love. She puts a lot of her stuff up there for free to share with the world because she's awesome like that. Okay. So on the inside then, ROID stands for range. O stands for output. It's your Y values. And it's your dependent. Okay. Range, output, Y values, dependent. Okay. So that's just a reference on how to find things. Okay, you can set that aside. We are done with that. I'll show you how this all glues in once we're ready to glue. Okay, these other two full pages are going to fold into booklets like we did that other one. So you're going to fold it first, hot dog style, with all of your problems on the outside of the hot dog. Hot dog, hot diggity dog. Sorry, my daughter's obsessed with Mickey Mouse Clubhouse right now, so.
Man, I miss those.
So, doesn't matter which book you fold, we're going to fold them both first. So, you want to fold it in half hot dog style? Okay, both of them are going to fold the same exact way. Doesn't matter which one you fold first. Okay, so fold it in half hot dog style. Then you're going to fold it in half again. and fold it in half one more time. So your title should always be your front page. Okay. So you should have title on the front, blank on the back by the time you're done folding. Okay. Title on the front, blank in the back. Fold both of those, please. That's 1 and 2. La, 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 la. And then I found this really neat domain and range activity that you can glue into your notebook so you can practice domain and range on your own. And the cards that I gave you for in it actually have the answers on the back, so you can work it, check it, work it, check it. Okay. Again, domain and range is probably one of the hardest concepts for y'all, especially when it's from a graph, unless it's a discrete function. Discrete functions are the easiest.
Can we go ahead and fold both of them?
Yeah, fold them both. We're going to start with discrete functions, but fold them both. Okay. Good. Okay. Domain and range of discrete functions. So a discrete function is just a list of points or just points on a graph. It doesn't flow from one to the next to the next. Okay. So discrete functions are going to look like this. Okay. You can see it as a table. Okay. So as a table, to list your domain, you just list me all of your X values. So your domain here is -5, -2, 0, 3, and 6. Okay. It's literally just a list of every X value they give you. Okay. This is why I said discrete functions are the easiest. Okay. Continuous functions is going to use less than or greater than, less than or equal to, greater than or equal to type of an idea. Okay. Your range then is a list of all your Y values. So your range is -23, -14, -8, 1, and 10. Okay. The thing to remember with discrete functions, if I use the same number twice in my X's, I only have to list it once for my domain. Okay, I don't have to list it a second time. Okay. Same thing with a mapping diagram. Again, your domain is a list of all of your x's. Which ones are your x's? It's your left. Okay. My x's are my left. Oh, they actually labeled it at the top. Okay. So x's, and remember, f of x is function notation. So f of x is your y. So your domain here is -4, -1, 0, 2, and 7. Your range then is -5, 0, 1, 2, and 4. By the way, today's Kylie's birthday. Woo! Now she's famous on YouTube.
Oh,
We on YouTube.
Where's
LOL.
the cake at?
Oh, yeah.
At home in my fridge.
Did you eat it yet?
My daughter killed a huge slice last night. She's literally sitting there with the icing. Strawberry cream cheese icing, strawberry cake. Oh. Delicious. Right, bee jelly. Y'all should just be jelly.
I want a pie right now.
Okay. I can give it to you as a list of points. Okay. So again, my domain is every x value. So this is x. 0 is your x. 1 is your x. 6 is your x. So -2, 0, 1, and 6. Okay. They also usually list them from your smallest to your largest. So if you notice, your y's aren't in order at the top, but normally when they'll write out your range, they'll put your smallest y value up to your largest y value. So when you write your range for this one, we should start at 0, go to 1, go to 3, and go to 4.
So we should always start with the smallest.
They usually go from smallest to largest. So if you would write it out and it would be a multiple choice question, just know that your answer is not wrong. If you write it not in the order that they have it in, they can rearrange it. So a lot of people would have just wrote 3, 4, 1, 0, but when they're looking for the answer, it's probably going to be 0, 1, 3, 4. Okay. Here's what a discrete function looks like as a graph. Okay. I can list out all of those points. So this little point up here is -4, 5. This point right here is 2, 4. This is -1, 1. And this is 3, -2. Okay. The biggest mistake that I see when you're listing domain and range from a graph is for some reason you do not list your points x, y. Okay. Please make sure your x value comes first, your y value comes second. So now my domain, my smallest x is -4, then -1, then 2, then 3. And my y's are -2, 1, 4, and 5. that is. Okay. In this table, notice that I've got 2 -3s in my x's and I've got 2 +2's. So when I write my domain this time, though, I only need to list it once. So I only need to list -5, -3, 0, and 2. On my y's, I have 3 6's listed. Again, I only need to list that once. So my range here is -5, -3, 0, and 6. Okay. Last one, here's another graph. Okay, so I would list out all of your points first. So we've got a point at, this is -2, 4, -3, 0, 3, 2, and 0, -4. So that makes your domain -3, -2, 0, and 3. And your range -4, 0, 2, and 4. Questions or problems? Okay. So, like I said, discrete's pretty easy. The ones that everybody struggles with, finding domain and range of continuous functions. All right. Okay, so a continuous function is something that flows from one point into the next point, into the next point, into the next point. Okay, it can continue flowing out to the sides. It can continue flowing up or flowing down. Okay, so you have to pay attention to the fact of, is it a dot or does it have an arrow? Does it continue? Okay, so these first ones are pretty easy. Okay, your domain. What is your smallest x value on your graph? -2. Okay, my x's go as far out as -2. How far to the right does my graph go? +4. Okay, and my graph is continuously flowing in between those two. So that means my range is -2 is less than or equal to, because it's a solid dot, which means -2 is a point on my graph, and domain is x's, so it's x, which is less than or equal to +4. Okay, so that means if I told you x is 1, there's an answer for y. If I told you x was 2, there's an answer for y. If I told you x is -2, there's an answer for y. If I tell you x is 4, there's an answer for y. But if I tell you anything outside of those bounds, so if I say x is 5, there's no answer for y. So that's not part of my domain. In order for it to be a part of my domain, there has to be an answer for my y when I pick an x value. So anything from -2 up to +4 will give me an output. Does that make sense? Okay. So range. Range is how low to how high. So what's the lowest y value of my graph? -3. My graph goes clear down to here. My graph goes clear up to what point on my y? +4. So that means my range is -3 is less than or equal to y. Again, we're dealing with y values now, which is less than or equal to 4. So that means if I tell you y equals 3, you can give me an x value. If I tell you y equals 0, you can give me an x value. But I can't give you an x value if I tell you y is 5 or y is -5. It's outside of my range. Okay, I can only give you answers between -3 and +4 because that's the only areas that my graph will cover. Okay. Moving over. Okay. X again. How far to the left? How far to the right? So -2. So -2 is less than or equal to x. And the farthest right my graph's going to go is +7. How low? -3. So -3 is less than or equal to y. And how high? +6. Less than or equal to 6. Question. Okay. 4 more of these. Okay. This one. What do you notice that's different about this graph that the other two did not have? It has a white circle. So you remember when we were solving inequalities and we did the open circle if it wasn't included and the closed circle if it was included? They can do that on these as well. So all this does, it doesn't change your numbers. So I still go -2 to the left and +4 to the right. Okay, so -2 is included. So -2 is less than or equal to. It's included. But when I get to 4, 4 is not included. So this is now just less than. So that means I can get to 3.999999999 and still have an answer. But as soon as I touch 4, there's no answer for 4. Okay. So this open circle at 4 is the reason that we only use less than.
Does that stand for the positive 3 on the Y too? Or no?
Oh, I'm sorry. That should be, wait.
No, I'm saying.
Yes. When you do your Y values as well. Okay. So when you do your Y values as well, it's a closed circle at -3. So it's less than or equal to. And it's an open circle at +3. So it's only less than. Again, because of that open circle, that's what causes that less than. So my Y values can get to positive 2.9999999, but it will never, ever touch 3. There is no X value when Y is 3. 3, 4 is not a solution. It will not work. Okay. Uh-oh. Take a look at the next one. Now you've got a dot on one side and an arrow on the other. So what's the arrow mean? It's going to continue going. Okay. So my graph will not go any farther left than this point. But as I follow it to the right, it's going to continue going. It does not stop. So you don't have restrictions on both sides. You only have restrictions on the left. So you can write this as X, and it's going to the right. So it's greater than or equal to 0. So that means you have answers for 0, 1, 2, 3, 4. I could have answers for 72. Clear out on the positive side. It will continue going. Now, can you see that from this graph? No. But if we extended it out, yes. Same thing with your Y's. So my Y's will never go any lower than 0. But as this graph goes to the right, it's also slightly moving up. So it's going to continue in that upward direction. Okay, it's not moving up really fast, but it is going to continue to go in that up direction. So Y is greater than or equal to 0. You're not going to learn about these functions until Math 3. This is a picture of an absolute value equation. Okay. So, in this one, your x's. Uh-oh. What's happened? Okay. So, your x, how far to the left is my graph going? With this arrow over here? Infinity. Okay. So, it's going to continue going to the left and to the left and to the left. Sorry, let me turn this way. because y'all are looking at me like I'm crazy because I'm pointing to the right in your direction. Okay, so it's going to continuously continue to go to that left side. What's it doing on the right? It's also going to continue going to the right. So no matter what X value I put in, whether it's negative 128 up to, it could be 7,864, I will always have an answer. Okay. There will always be an answer. So your domain, when it continues to go in both directions, is all real numbers. Okay. They also, that symbol looks like this. Okay. All real numbers.
Is that like I and R?
It's like, I don't know, it's just like an extra line on the outside of the R. Okay. Okay. So if it continuously goes in both directions, to the negative and to the positive, all real numbers. Okay. My range, though. What's happening with my range? It stops at -3. It's not going any lower than -3, but it's going to continue to go. Restriction on the range. Range is always going to be greater than or equal to -3. It's never going to go any lower than -3. All of my Y values are going to be -3 or above. Actually, let me put the arrows here for the domain. Okay. Over here. What's my lowest X value? -5. What's my highest X value? +6. So we're -5 and we're +6. Okay. Which one of these do I need to include the equal sign? The first one. Okay. This is a closed circle. This is an open circle. Okay. I like this one because the circles show your domain, but they don't show your range. You can't use the circles for your range. How low do I go?
-6.
-6. Up to what?
2.
+2. So -6 is less than or equal to Y, which is less than or equal to 2. So unless you clearly see an open circle, it is always less than or equal to. Okay.
Can I go to the restroom, please?
Yes. Okay. We're going to do 2 word problems with domain and range. Bless you. Practice at 4 today. Please dress for the weather. Okay, domain and range restrictions. Okay. A lot of times when you're dealing with word problems, there is going to be a restriction, mainly because you're dealing with people. You can't have -2 people. Okay. So think logically. If your people is your input, you can't have a negative person. Okay. They can have a negative attitude, but they have to be there. So they're a solid person. Okay. You're dealing with money. Unless somebody's stealing from you, you ain't going to have negative money. Okay. You're selling something. You can't have a negative amount of tickets. Again, unless somebody's stealing from you, you're not going to have negatives. So keep that in mind while we're doing these. All right. So it says a local theater sells admission tickets for $9. Okay. On Thursday nights. A capacity the theater holds is 100 customers. So what is my independent variable and what is my dependent variable? What can I control? The amount of people. Okay. The amount of people. Okay. The amount of money that I make depends on how many people show up. Okay. I can't sell tickets if nobody shows up. So my independent variable is the number of people or the number of customers. And my dependent variable is the money raised. So my money depends on customers. I can't make money if I have no customers. Okay. Would you consider this discrete or continuous? Why? Okay. So this is going to be discrete. Think about it. Okay. Continuous means it flows, which means I could have 1.3, 1.6. Can I have point something of a person? Okay. We're not axe murderers. We're not chopping people up. Okay. So this is going to be discrete. My domain is never going to go lower than 0. Okay. I can't have negative amount of people. So my domain is going to be 0, 1, 2, 3. When is my domain going to stop? Why 100? That's the maximum capacity. So we stop at 100 because that's the max capacity. Okay, so we've restricted your domain and range. So what's my range then? What's the smallest my range can be? 0. If I have 0 people, I've got 0 money. If I have 1 person, I make how much? 9. If I have 2 people, 18. What's the highest amount I can have? $900. Okay, if my max capacity is 100, we're not going to talk about those generous people. You got a good thought process, though. I like it. He's thinking extra hard. Yes. This next one about to make me hungry because all I can think about is my grandma making some homemade applesauce. Oh.
How do you make homemade applesauce?
You boil the apples and you add your own cinnamon and crush them all up and
Is it good?
yes.
How do you
It depends. Honestly, it depends on the type of apple you use too.
Can you go back up, please?
Yes. Okay. Joy's grandmother cans homemade applesauce around the holidays to raise money for the local food bank. She earns a profit of $2.79 for each jar she sells. So, what depends on what?
The money depends on the fundraising.
Okay. So, her profit or her money depends on the number of jars she sells. Okay. I've got to sell jars to make money. Okay. Normally, when you're dealing with money, money is usually your dependent variable. Okay. So if money depends on the number of jars, that means money is my dependent and my independent is my number of jars. Would you consider this one discrete or continuous? This one's also going to be discrete. Okay, she's not selling half jars. She could, but it doesn't indicate that she does that. Okay, you're not going to walk in and be like, I want 1.17 jars. She's going to look at you like you're crazy. Okay, so how low can my domain go? My domain's the number of jars I'm selling. 0. I can sell 0 jars. 1 jar, 2 jars, 3 jars. When does my domain stop? When she runs out of gas and she stops making applesauce. So guess what? This is never going to stop. Okay? It's going to continue going. There is no maximum capacity. She could make applesauce until her fingers fall off. Okay? There is no restriction on how many jars. But again, she can't make a negative amount of jars. Okay? Let's talk about your range. How low can your money go? 0. If I sell 0 jars, okay, $2.79 is for 1 jar. How much do I make for 2 jars? Ooh.
25.
5 something.
$5.58. Good. Okay. When is my money going to stop? When am I going to stop making money?
When you stop selling.
When I stop selling jars. So my range can continue going in those increments. Okay. But it will never, ever stop.
So, discrete and continuous, what does that depend on?
So discrete and continuous depends on if you can break down items. So,
What pound of work?
if you're selling stuff by like the ounce,
Like a bread, a big piece of bread, and you have to put it.
so I can sell you 0.222 of an ounce. Okay, so I can break that into smaller increments. We actually talk about this in discrete math that I teach to my seniors. Yes, there is a math literally called discrete. That's what I teach to seniors. And it's lots and lots of fun. All right, so let me show you what page 41 is going to look like, because that's our next page to glue in. Okay, page 41. Okay, page 41 is going to house your 2 booklets and your Dixie Roid. So you're going to probably have to put your Dixie Roid as far to the top left corner into the seam as you can so you can fit both of those booklets in there. Okay. Then I've got one more piece that you're going to glue in that I still have to pass out, which is what you can do for independent practice. Okay. Because, like I said, everyone seems to struggle with domain and range. So the more you practice, the better off you are.
So you said we have a unit test, Friday?
Friday. Tomorrow, when you come in, we are going to review. So I'm going to let you guys pick your own groups tomorrow to review. If you'd prefer to work independently, I mean, by all means, but you probably will at least want to work with a partner. Okay. You're going to review solving equations. You're going to review relations versus functions and domain and range. So there's page 41. On page 42 is that half sheet that we just did.
Bless you.
Okay. Again, tomorrow we will update your title page.
Are we doing that in test for next week? Oh my God.
Okay. So let me show you how this last thing is going to look. Okay. Listen. Okay. So somebody came up with this genius idea. Okay. That in your notebook, you can have a domain and range practice. So I'm going to hand you a piece of green paper and you're going to cut out the shape like this. Okay. Then I'm going to give you, I printed out 16 different graphs. Okay. So you're going to cut these graphs. Okay. I would not cut them as big as what's on here. I would go as close to the graph as you can without cutting any of the graph off. Okay. And let me show you what this is going to look like. Okay. So then, okay, you can take your graph and it can sit in here and you can show yourself, here's your domain from here to here. Here is your range from here to here. Okay. And I've provided the answers on the backs of these. So as you practice, you have the answers to look at. Okay. And then I've also made you all those little envelopes again to put all these cards in once you've cut them out. Okay. So you're going to glue this piece in. You're going to glue yourself your little envelope at the bottom. You're going to cut out your cards and put them in the envelope. Okay. True.
Doing that today?
Preferably, yes. You might not get all your cards cut out today, but I'd at least get this green piece cut out and get your envelope glued in. Come on. Seriously? You don't want to end today? Okay.